Today I will discuss with you the blood vessels of the bones, the arterial supply and the venous drainage, and the innervation of the bones and the lymphatics of the bones. Right? So arterial supply of the bones. Arterial supply, each long bone obtains at least one nutrient artery, which is commonly a branch of the major artery of the region. The nutrient artery, also termed the diaphyseal artery, enters into the bone through the nutrient foramen near middle of the bone shaft. You could see this. This is the nutrient artery, this red. This is the nutrient artery. Follow the laser. Yes, this is the laser. This is the nutrient artery. Label here for you. And it enters through nutrient foramen into the bone, diaphysis, long bone. Other than the nutrient artery, a long bone obtains blood from three other sets of arteries which enter the bone through various small vascular foramina lying in different parts of the bone. These arteries are the metaphyseal arteries, the epiphyseal arteries, and the periosteal arteries. The course of various arteries within bone, their branches and mode of termination are discussed now. We'll discuss with you, right? You could see this. These are the, epiphyseal artery. The epiphysis, the end is the epiphysis, end of a long bone. This is the epiphysis. This is the epiphyseal artery. And this is the metaphysis. Metaphysis, the junction of the epiphysis, and the diaphysis, the shaft. So this is the metaphyseal artery, right? So let's move on. The nutrient artery gets entered into the shaft of the bone while the nutrient foramen runs oblique course through bone cortex in the nutrient canal and afterwards passes into medullary cavity where it gets divided into ascending and descending branches. Let's again go to the picture. Here you could see this. Here it enters into the long bone shaft via the nutrient foramen and divides into ascending and descending branches. And these branches termed the medullary arteries run toward the ends of the bone. As they reach the epiphysis, medullary arteries get divided over and over again and give rise to various terminal branches. Several of these branches are end arteries, which get drained into venous capillaries that get opened into a big central venous sinus lying in the central part of the medullary cavity. Right? You know the medullary cavity. If you want to see it again, you could see this again. Follow the laser. This is the medullary cavity. And arterial supply of the bones continues. But a few of the branches of the medullary arteries make an anastomosis with the terminal branches of the metaphyseal and epiphyseal arteries. This establishes a key collateral route for the blood supply to the shaft of the bone in case of a medullary artery gets damaged in case of a bone fracture. Here you could see this. And the arterial supply continues alongside their course. Central branches and the cortical branches come from medullary arteries. No, medullary arteries give central branches and the cortical branches. Central branches, what are they? They convey blood into a meshwork of the medullary sinusoids that lie in bone marrow. These sinusoids get drained into a central venous sinus. Cortical branches of the medullary arteries produce capillaries which pass into the bone cortex to course in the Haversian canals. When I will discuss with you the histology of a bone, you will come to know the detail of the Haversian canals, the osteons, the lamellae. At source of bone, cortical capillaries are connected to periosteal plexus of capillaries. You could see this. The metaphyseal arteries also numerous vessels that arise as direct branches of main regional arteries that course near the bone ends. Shown you the picture of the metaphyseal arteries. They entered into bone via numerous vascular foramina lying just inner to the vascular epiphyseal line. Inside the bone, metaphyseal arteries get divided into branches that make an anastomosis with terminal branches of the medullary arteries and in adult bone with the branches of the epiphyseal arteries. Here you could see this again. This is the metaphyseal artery. Here you could see this. This is the labeled one. This is the metaphyseal arteries. Follow the laser. The epiphyseal arteries. You see the picture of the epiphyseal artery. This is the epiphyseal artery. This is the epiphysis, the end of a long bone, and this is the epiphyseal artery. Um, they arise from the arterial anastomosis that are made around the joints by branches of the neighboring main arteries. At each end of a bone, several epiphyseal arteries get entered into the bone via numerous vascular foramina lying out to the epiphyseal line. Within the spongy bone of the epiphysis, the epiphyseal arteries get divided into branches that make anastomosis with each other to make several arterial arcades. From these arcades take origin the end-arterial loops, most of which bring back blood to the epiphyseal venous sinusoids. And arterial supply continues. Though a few of these end-arterial loops pierce the slender compact bone present underneath the articular cartilage to lie in calcified zone of this cartilage. These arterial loops can have some role in providing nutrition to the deep portion of the articular cartilage. As discussed before with you, in an adult bone, branches of the epiphyseal arteries also make anastomosis freely with those of the metaphyseal arteries, right? And you could see this epiphyseal artery and the metaphyseal artery, their branches make free anastomosis with each other. And on the other hand, no such anastomosis is present in the growing or the immature bones for the reason that epiphyseal and metaphyseal arteries cannot link up with each other owing to the presence of the intervening epiphyseal cartilage. The periosteal arteries get derived from arteries of those muscles that are attached to bone. So the periosteal arteries, you could see this periosteal as well, periosteal artery. This is the periosteal artery labeled over here for you. This is the periosteum of the bone, the outer side, right? And this is the periosteal artery. Branches that arise from muscular arteries, they make plexuses over and within the periosteum, the outer covering of the bone. Arterial twigs taking origin from these plexuses get entered into compact bone of the shaft at several points and make anastomosis with the cortical capillaries running in the Haversian canal or the osteon. Remember that cortical capillaries get derived from medullary arteries. I told you already. Consequently, besides providing nutrition to the periosteum, the periosteal arteries help in the blood supply of the outer part of the bone cortex. Now, the venous drainage of the long bones. What is this? As discussed before, a big venous sinus is lying in the center of the medullary cavity, and the sinus obtains blood from the meshwork of the medullary sinusoids that are fed by central branches of the medullary arteries. This sinus also obtains veins that send back blood from end-arterial loops constituted by the terminal branches of the medullary arteries. The central venous sinus gets drained via the nutrient foramen by way of the diaphyseal vein, which go along with the nutrient artery. Here you could see this, and this is also labeled the nutrient artery, and it's accompanied by the nutrient vein. Here you could see this. Follow the laser. This blue is the nutrient vein. And in the periosteum, a periosteal venous plexus is also present that gets drained into venules of the muscles that are attached to the bone. Cortical capillaries are connected with periosteal venous plexus and therefore drain their blood into the muscular veins. This displays that in the shaft of the long bone, blood flow through the cortical compact bone takes place centrifugally, that is, from the center toward the periphery. Cortical branches of the medullary arteries feed cortical capillaries that drain into the periosteal veins. Spongy bone of the ends of the bone gets drained by the several metaphyseal and the epiphyseal veins that pass out through numerous vascular foramina to join neighboring veins. Now, also a line about the lymphatic vessels of the bones. Lymphatic vessels are also plentiful in the periosteum. And the innervation in the last. Innervation of the bones. Nerves go along with blood vessels supplying the bones, and the periosteum is abundantly supplied with sensory nerves, the periosteal nerves, which carry pain fibers. Let me show you the nerves present over here. You could see this. This is the nutrient artery and vein, and this is the lymphatic vessel, just discussed with you. And this is the periosteal nerve, right? This periosteum is, pain sensitive. Often a MCQ comes, periosteum is nerve sensitive due to this periosteal nerve. So it is periosteum is particularly sensitive to tension or tearing, which explains acute pain from bone fractures. Bone itself is relatively sparingly supplied with sensory endings, right? So vasomotor nerves within bones cause dilatation or constriction of the blood vessels, thus regulating blood flow through bone marrow. So now this was all about the long bone. Now the blood supply of short bones. A short bone obtains several fine blood vessels from periosteum that get entered via the non-articular surface of the bone. These vessels provide blood supply to the compact and the spongy bone and the bone marrow. The venous drainage takes place by one or two veins that leave via vascular foramina on the non-articular surfaces of bone. Now the blood supply of the flat bones. Flat bones of the skull obtain arterial blood by several fine vessels that take origin from the periosteal plexuses. The veins are large and are thin-walled. They run in the tertius canal in the diploe. A rib obtains blood from periosteal arteries and a nutrient artery which gets entered into bone just beyond its tubercle, right? This was about flat bones and blood supply of the irregular bones. Now, yes, see, this is the last slide. Blood supply of the irregular bones. Large irregular bones like hip bones and the scapulae obtain several vessels from the periosteal plexus. Besides, they are usually provided with big nutrient arteries which penetrate through compact bone into the cancellous bone. Branches of both the systems, with the periosteal and the nutrient, make anastomosis with each other freely. Their veins leave from surface of the bone. A vertebra obtains arterial supply via two arteries, one that enters the bone close to the base of the each transverse process. The spongy bone containing red marrow gets obtained drained via two large vessels called the basivertebral veins that converge to a foramina on the posterior surface of the vertebral body. So I thank you very much for watching my video. So please do subscribe and like and put a comment down below and share. Stay blessed. Thank you very much. Bye.